Hello. Okay, we will start a new program, a new course. It's about Eurocode, precisely Eurocode 7. As you know, Eurocode 7 is the European code, European norm that deals with geotechnical design. Okay, so this program is to talk about everything, maybe not everything, but almost everything about this Eurocode. Okay, Eurocode 7. So if you want to learn how to design geotechnical structure following European norm, Eurocode 7, this program is for you, okay? And as usual, we will do both French and English. For each section of this program, each video will be done in both languages. And a link for each version will be available in the comment. Okay, so I hope you will learn something from this program. So here are the content of this program. The first chapter is just about general, so it notes that just generally talking what is Eurocode and how this Eurocode 7 started. And chapter 2 is about basic of geotechnical design. The third chapter involves ground investigation and testing. Okay. And we will talk about shallow foundation in chapter 4. Chapter 5 deals with the anchoring. Well, chapter 6 is about retaining structure. First part, retaining structure. The chapter 7 is second part of retaining structure. This one is mainly gravity walls. The number 2. And chapter 8 is about slope stability, embankment, and hydraulic failure. Deep foundation will be discussed in chapter 9, and overall stability of structure, chapter 10. The last chapter will talk about all the geotechnical design that are not included in the previous chapters. Okay, so geotechnical design and construction matters, the other part of geotechnical design. Okay, in this video, maybe we'll talk about this too. As I told you, the chapter 1 is just one slide, and just general information. So we don't need to spend time on this. And after that, we'll start chapter 2. And this chapter 2 involves a lot of information. So we'll do it in maybe several videos to finish chapter 2. So chapter 1, general information, just one slide, not that much. So we know that in European Union countries, construction sector, it means just in Europe, not even in European Union country, all Europe actually. Construction sector contribute to about 10% of GDP and 50% of the capital formation. Like more than 2 million people are involved in this sector. So it's kind of very important sector for Europe. So Eurocodes, actually there are many, and these codes give guarantee for safety, construction safety under extreme conditions. And they are very crucial for global competition because European countries need to compete also in the world. So all 58 Eurocode parts, so there are 58 parts of this Eurocode are allowed to be used since 2007, and they are benefiting in Europe and also beyond some country beyond the European Union. Let's say just beyond Europe. And training for engineers and collaboration between this research center, Directorate General Joint Research Center, which is here, DG JRC, and this one also, Directorate General Enterprise and Industry, and the Committee of European Standardization Organization. These three, they actually supported the implementation of and development of this Eurocode and training engineers. Okay, so the reports include policy support, technical examples, drafts, standard, background information, and scientific insight. So this document enhance Eurocode understanding and application. So all these documents are just made to make it easy for people to understand and apply this Eurocode. So this course, this program is standing as this number 2 technical example document. Okay, so it will, in this program, I will try to give you detailed example like applications. Okay, and hopefully it will help you to understand the Eurocode 7. So design example, we will discuss many design examples in this program, but they are not exhaustive. So because practice, there are different practice methods across European country. So in this program, I will try to include many practice in many countries, many European countries, mainly UK, France, maybe Belgium. I think at least 5 countries. But anyway, the main objective is to show you the specification that each country is using, because it's Eurocode 7, but each country also has just small detail difference for each country. Okay, now chapter number 2, basic of geotechnical design. In this chapter, we will talk about this point. The first section, it is the overview. This one we will talk about this in this video, and next in the following videos we will try to talk about this part. Number 2 is design requirement, action and design situation, limit state, supervision, monitoring and maintenance, and summary of key point. Some example also, worked example, combination of action. Okay, so in this video, we will just talk about this part, the first section, the overview. Okay, for the overview, we know that Eurocode family design standard. So in this chart, we have this one, the EN European norm 1990, which is about structural design, basis of structural design. 1991, action on structure, means load on structure. You can see maybe this is like snow and rain, wind, like natural events. Anyway, actions, load on the structure. And 1992 here is about design of concrete structure. 93, design of steel structure. 94, design of composite concrete and steel structure. So both concrete and steel. And design of timber is 95. 96 is about masonry structure. 97 is geotechnical design. This is the one we will discuss in this program. This is our objective here. Geotechnical design. 98 is about earthquake resistance. And 99, which is design of aluminum structure. Anyway, as I said, the 97, the geotechnical design is what we want. This is our concern. So for this one, Eurocode 7, geotechnical design, it has two parts. Part 1 is just about general rules. So these general rules, EN 1997, 1, because this is the part 1, published in 2004, and the geotechnical Eurocode 7 geotechnical design part 2 is about ground investigation and testing. So EN 1997 2. So this is second part. That one was published in 2007. So these two parts, actually, before it was 3 parts, but the third part was like combined with this second part later. So we have only two parts of this Eurocode 7. So in this program, we are combining both part 1 and part 2. We put both together because I will try to mainly talk about practical cases and give a lot of examples on how to design all the type of geotechnical structure. So the development, let's talk about just a small history about the development of this Eurocode 7. Not all Eurocodes, only the 7, Eurocode 7, only geotechnical one. Development and implementation of this Eurocode 7. So the first point, background, from 1975 to 1980. So this Eurocode 7, part of the Eurocode series, everything emerged from the European Commission initiative in 1975. They wanted to standardize the construction regulation in all European countries, the member of European Commission state. So the objective was to replace national standard because each country has its own national standard before Eurocode 7. So they wanted to make it one code for all the country to harmonize approach. So this Eurocode 7, which is about geotechnical design, was developed with the input of International Society for Soil Mechanics and Geotechnical Engineering. Maybe you know about this. They have a journal also. So they did the first part, but they didn't finish it. So overcoming a lot of challenges, it became a comprehensive geotechnical design standard adopted by many countries, including also non-European countries. Okay, the part number 2 of this history of the development of Eurocode is the model code. The model code, the work about model code was done between 1981 to 1987. This is just about the model of the code, not the code itself. Okay, so the International Society for Soil Mechanics and Geotechnical Engineering and Foundation Engineering, I told you before, it is here, Geotechnical Engineering. They formed a subcommittee led by this professor, Niels. I'm not sure if I read his name correctly. He led the first committee, the subcommittee actually, because this is committee only for Eurocode 7. And they tried to draft the Eurocode 7 for geotechnical design. This is him, Professor Niels. And I'm not sure if the name is right, but he is he's Danish, I think. Danish Engineering Academy. So he was the chairman and convener of this Eurocode 7 from 1980 to 1998. So this committee, he represented from all European Economic Committee, community member country collaborate in this process. So it means from each country, one person was selected, I think, and they made a representative. And this photo is showing maybe almost all of them. This photo was for taken, I think, in 1983, committee member, the meeting they did in January 1983. If we take on this photo, the first row from left to right, this first person is Trevor Ireland. And actually this reference is from him, I think. And we have this one is Demetrios from Greece. I'm not sure if I can read their names, but the countries, at least I can read. Greece. And the Professor Niels, this one is just here, I think. And the last one in the first row is this one from Netherlands. From Netherlands. Yes, Professor Niels is from Denmark. Danish Engineering Academy chairman. He was the chairman of the group. So in the middle row, the middle one, we have Germany representing, I don't know this one, but we have also Ireland. The back row, UK, Belgium, France, Italy, and also Netherlands. So this was the first, the committee, I think, from 1981 to 1987. Yes. So the International Society for Soil Mechanics and Geotechnical Engineering involvement was debated because actually they are not specialists for standardization. But despite of that, they try to do very good work and adding some also new member, a new member for the European Economic Committee country. And after 22 meetings over 6 years, the draft model code, because this was for the model code, was completed and submitted to European Commission in 1987. So this was contribution of from European Geotechnical Society showcasing. This was the first draft they submitted, this photo. Okay, after 22 meetings in 6 years. So we can read here, Eurocode 7, December 1987. The report prepared for the European Committee. Yeah. So after this first part, we have also the first draft, because the first submission was just about the code, and after that the code comes the first draft. Now after submitting the model code, just the model, small drafting panel of 7 members, including the same professor, I think he is here, including the same professor, him, was formed by the European Commission. So this panel worked independently for Commission, but they faced a lot of challenges because of the expanding scale of the Eurocode work. And because of these challenges, in 1989, due to these challenges, Eurocode work was transferred to the European Committee for Standardization, CEN. I think CEN means Comité Européen de Normalisation en France, in French. Okay, so because they are not specialists, and due to the lot of to the challenges, it was transferred to this CEN. So before they do the transfer, they submitted the initial incomplete draft of Eurocode 7 to the European Commission in November 1989. And this is the draft actually. The first draft. Previously, they submitted the model code. Okay. And in 1989, they submitted a incomplete draft, the first incomplete draft. This is just a draft. So you can see here preliminary note for publication. This is very 19 something. So from chapter 1 to chapter 10. Okay. First incomplete draft, November 1989. Yes. So after from this draft was the first the work they did before transferring the work to the European Committee for Standardization. I will just keep these photos here. So after the first draft, now comes to the trial version of Eurocode, which took from 1990 to 1994. So this Eurocode work was transferred to European Committee of Standardization on January 1st January 1990. So the CN established a TC 250 structure Eurocode committee, like small group for each Eurocode branch, to oversee the work with representative from a national standards organization. So the subcommittee SC7, that subcommittee was for geotechnical design, was formed for Eurocode 7, and including still the professor Niels, okay, in Denmark. So this draft of Eurocode 7 were then sent to a CN member country for feedback. Okay, so resulting in over 1,800 comments. So the draft made by these people was sent to each country for comment. They received over 1,800 comments. And a project team 1, part of this subcommittee, responded to do all these comments. They tried to answer to the comment. And then a trial standard version of the Eurocode 7 was completed after 22 meetings and ratified by the CN in 2003, and was published in 1994. Okay, so this was the first publication of the trial version, and it was something like this. This was just trial standard version of Eurocode 7. Still, the trial version stayed from 1995 and to 1998. So after the initial publication of this trial version of Eurocode 7 in 1994, this trial version, you can read it here, I think, it ENV 1997-1 in 1994. So the international seminar was held in 1996 to address these concern, the comment, the over 1,800 comment, to address this concern and indicate general agreement on the philosophy of the Eurocode. This led to the decision to convert the trial version of Eurocode to the standard Eurocode we know today. So to address the specific concern, work group 1, WG1, was established in 1997, which included representatives from the European Committee for Standardization member country. So this work group 1 focused on technical aspect, and they introduced new cases with partial resistance factors, case D1, D2. You will know about these two later in this program. So they expanded the section in the standard. And after the trial, then it came to the standard version from 1999 to 2004. So after this, completing the draft work by the working group 1 in 1998, new project team 1, PT1, was formed in 1999 to convert the draft into the formal EN European norm standard. So this project team 1, PT1, led by this professor, I cannot read his name, but at least I can read Ulrich. I don't know this one. Finalized the draft version of Eurocode in October 2003. Introducing the design approach and addressing all the concern from the trial version of Eurocode. So this draft was unanimously approved. They used vote to approve the draft. they did voting from January to March 2004. So the European Committee for Standardization ratified it, and the European Standardization for Geotechnical Design, this Eurocode we know now, right now, General Rule 1, was approved, ratified on April 23rd April 2004. That's the date of the ratification of this European standard for geotechnical design, means Eurocode 7. Translation were prepared because Europe, there are many languages. Translation were prepared and the standard was published in this ratification April 23rd April 2004, and publication November 24th, 2004, same year. We've also, with this reference, releasing guide to help implementation of this Eurocode 7 in the same year, 2004. So that is how they obtained this Eurocode. So about the implementation, which took from 2005 to 2010, Eurocode became national standard in each country that is member of CEN. Okay, and specific parameter in a national index. That is very important for you to know because there are some specific parameter for each country, despite the Eurocode is the standard code. If you change from one country to another, there are some very specific parameter that will change. So with a coexistence, after introducing the Eurocode, they allow people to have both national code and Eurocode until 2010. So after that, after 2010, then Eurocode 7 became, like, it governed the design practice. And then discussion and workshop held to establish parameter for each implementation. Now comes monitoring and maintenance of the Eurocode 7. So the European Joint Research Council in Italy oversees the implementation of Eurocode across member countries by maintaining database for their choices parameter, because each country will choose the parameters. So if a country decide to change the parameter, they have to give a good reason, provide explanation. And there is a maintenance group for this Eurocode 7 established to collect correction and propose revision. So I think they revised the code in 2009, but I'm not sure. Just 5 years after the first publication. They had also some difficulties, challenges during the development. And the main challenges for this draft file of Eurocode are these three following challenges. The first one is how to harmonize the geotechnical design, because there are many countries and they want to harmonize the geotechnical design with structural design. The geotechnical design need to be along with structural design, means the Eurocode 1990. And they also need to take account specific parameter or specific feature of soil, because soil has very specific parameter. So that will result in unique nature of geotechnical design. The third challenge is what like for this code to be accepted to the European Geotechnical Committee. So about this, the number 2, the B, this table show, for example, the big difference between, because they wanted to take account to specific parameter of soil, and we can see here the difference between this for soil and steel. You can see the soil is a natural parameter material, but steel is material that we can manufacture material. So as a consequence, for geotechnical design, the property for soil are determined, not specific. So ground investigation and testing part of design process. We don't specify the soil parameter. We have to determine them. And soil also has 2 or 3 phases: liquid, solid. Liquid is maybe water, solid, the grain solid part, and also gas like air. Again, soil mechanics class. That still is only one phase, only solid phase is considered. So this means for soil, we need also to consider water and water pressure as well as soil. Not only soil is considered. And soil is not homogeneous like steel. A high variability. Steel doesn't vary too much. High friction. And it ductile. Compressibility also. Soil is very compressive. And non-linear and complex behavior. So all these specific nature of soil, parameter of soil, leads to very challenging work for the people who draft Eurocode 7. Okay, I think this is all. From the next video, we will start to focus in very interesting things. For this video, we'll stop here. So see you in the next video. Thank you very much for your time.